Do you
Let's do
remember?
it. Yes, what did you say?
Do you remember what we were doing?
Yeah, of course. We have done that ionizing thing, right? The levels one in which electron is jumping and coming back, if you remember that. You have asked me a question,
Yeah.
and that energy levels you were asking me, okay? So this is the one, once
Yeah.
again, quickly. There are energy levels, and when you say energy levels, you're talking about ionization level and you're talking about excitation level. What is meant by ionization level and what is meant by excitation level? Now, interesting fact. In general, electrons are moving in different levels. One is when electron go from one state to another state. Remember that it means you're talking about the state in which electron is called as ground state, whatever the state the electron has. If electron is in second, let's take an example, then you will understand. Let's suppose this is the shell, and electron is sitting here. Now, when you give it energy, what will happen? It will shift to an outer energy level because you want to break the bond between the electron and the nucleus, right? Now, if it shifts to
Yes.
the next energy level, it will be called as excitation level. Why excitation level? Because the electron is within the element. It just go to the other energy level. Once it go to another energy level, it will come back again. No issues. But if you give enough energy to this electron to go out of the go out of the element, then definitely electron will not come back because it is already out of the element. That energy level is called as ionization level. So
Yes.
ionization level means a level which is outside. Now I'll read it for you, then you will understand it. Electrons in an atom can have only certain specific energy levels. These energy levels are called electron energy levels. They can be represented as a series of stacked horizontal line increasing in energy. Normally, electron occupy the lowest energy level available, and this is known as ground level. Whatever energy, whatever level an electron is called as ground state. Now, it may excite to the higher energy levels by taking the energy. Now, what exactly it is? Electron can gain energy and move up the energy level if it absorbs energy either by collision with the other atoms of the elements or absorbing the photon or physical source such as heat. This is known as excitation level. When electron move up an energy level, they are said to be in the excitation. Like when you are upgraded, let's take an example. Let's suppose you are studying in a school in class 3, let's suppose, even though you are not studying in class 3 at the moment. Once you jump to class 4, I can say in physics that you are excited in physics. So you were in your ground state, then
Yes.
you shifted into the excited state. Why I'm saying this is excited state? Because you just jump to a next level, but you are still in the school. You understand me? But as,
Yes.
as soon as you shift into a class which is outside the school, like you are out of the school now, it's no more excited state, but we call it as ionization. So ionization means electron get enough energy to get out of the atom entirely. All right.
Okay.
These are the two different energy level one electron has. Okay. Now for this one, a diagram is shown here. I'll show it to you, then you will understand. What this diagram is actually showing it to you. Check it out. Initially, any particular level your electron is, it will shift up, right? What the energy is, let's suppose this is the ground level, the basic level. Remember that the basic ground level energy is normally negative 13.6 ev. That is actually given.
EV.
The calculation is not given in our course, so we will not be doing it. Otherwise, I think so. Calculation may be in our course. We have done this last time, right? We can calculate
Right.
EV, by the way. We can easily get it, but it's not in our course, so I'm not going into the detail. Just remember that the basic, or you can say the ground energy, where the electron can be, energy is called as negative 13.6. Now, what happened? Why negative 13.6? Why not positive?
Because electrons are negative.
No, it's not because electron is negative. You know why it is? Because you are providing it energy, not electron is giving energy. It is the energy that is used to knock out the electron from the atom. That's the reason it is negative.
Oh.
This is the energy of the electron in the shell for the time being. Now, if you check it out, you can say to that this is the energy of the shell. You means it is the force of attraction between electron and the neutrons. That is the energy electron has if electron has to travel in the ground state. Now, once the energy is being taken by any source, the negative energy will be reduced. Now, the energy of electron is reducing. Why? Because why reducing? Because the force of attraction definitely going to be reduced because you are providing extra force to reduce that force so that electron will be knocked off. So second shell, the energy is, let's suppose, negative 3.4 ev. ev is electron volt. If you remember, we have studied it in photoelectric effect, right?
Right.
Now, at this point, the energy is negative 3.4 ev. Further energy will give it to you. I mean, you provided, it will reduce to negative 1.51. The energy which is reducing is the force of a nuclear force between electron and the neutrons. You are breaking in, actually. That's what it is. Next energy shell is negative 1.51 electron volt. Now, check it out. The last energy level is what?
Zero.
Zero means what? Now, the
No.
energy level you are in is basically not a part of element anymore. You're out. You're free. You're a free man. That is the state we called as ionization level. So, we got excitation states and we got ionization level states as well. Understood?
Yes.
I want you to quickly write in, not write in a very much detail, write the basic things. What is your ionization? What is your excitation? And draw that diagram quickly. First, you write it down, then I will move my cursor down, and then you will draw the diagram as well. That is a topic I think you were asking me when we are actually when I teach you in a group, that will you be teaching that energy level topic or not? This is the one, right?
Yeah.
Mhm.
This is the one.
Even if you find any difficulties in the question, even though our classes are finished, you can message me, and if I be free, I will respond to you. All right.
Okay.
Whenever you find any difficulty and you want to ask any question, straight away message me. Inshallah, you will get your reply. You will get your answer.
Thank you.
No issues. No issues.
Okay. Can I see the whole image?
Oh, yes. Why not? There is a ground state. Okay. At a ground state, the energy level is negative 13.6 electron volts. And then you have different energy levels, which shows smaller energy. You don't need to memorize this negative 13.6 electron volt. It is just to show you that there are different energy levels. Okay. That's what it is. The nearest one is the highest energy. Then it slowly, gradually reduces, and it will at the end reduce to 0 electron volts. Part is line spectrum is a phenomena which occurs when excited atoms emit light or a certain wavelength which correspond to different colors. So what happened actually? Once you provide electron with an energy, it actually excites to a different energy level. And definitely once it come back into the same energy level, it actually gives you basically a wavelength, which is a different type of color. Okay. So emitted light can be observed as a series of colored lines with dark spaces in between. And these series of colored lines are called as line of atomic spectrum. So what my point is, let's suppose here the electron is, once the electron jump here, right? When it comes back, actually, it actually release, or it can emit a, a wavelength that can be seen in the form of a light. Okay. And that colored light is called as line of atomic spectrum. Each element produce a unique set of spectrum. Now, this is very important. Definitely, once the electron jump from ground state, let's suppose to n is equal to third stage, and then it comes back to the ground state, it will release a different type of lights having different spacing in them. So everything is a different for everyone. Like every atom will release different set of lights. And even if the electron jumps from one state to state number two, it releases different type of. I can give you an example, then you will understand it. Check it out. Let's suppose electron is here where there is. Okay, you provide enough energy so that electron jumps here in the first energy state. Now, because it's an unstable state, when it comes back to the first energy state, that is a ground state, it will emit out a photon, right? The color of that photon will be different. Am I right?
Yeah.
But the same ground state, when the electron jumps to the n is equal to 3 state, and then it comes back, the photon emitted light will be different. Same way, when electron goes to state n is equal to 4 and comes back again, the light will be different. So all the time, electron emitted having different lines, having different patterns, which they show it. That's what it says, that each element produce a unique set of spectral lines. Okay. No two elements emit the same set of spectrum lines. It means that if electron jumps to one energy level, definitely it will emit a different lines. When it jumps to a different energy level, will actually show different lights. So elements can be identified by their line spectrum. Now, element means if you're talking about hydrogen, the line spectrum will be different. If you talk about the helium, the line spectrum will be different. Right? So it also varies from element to element. Do you understand that, or is still a problem?
No, this is good.
Good. Okay. There are two types of line spectrum. One is called as emission spectrum, and one is called as absorption spectrum. I can simply tell you, emission means the spectrum you will achieve once the photon is emitted. And absorption spectrum is the one when the light or when the photon is actually absorbed. You will find out in a minute. I want you to quickly write the line spectrum, because this is the topic you really want to study, and I really want to finish this way. Basically, these colors are showing what? Only shiftings from different energy levels to the ground state. That's it. If you check the wavelength, it's very small, nanometers, 10 raised to power minus 9. So how come they be contributing in any sort of fire? Because fire means it should be very strong enough to, catch fire or something. So they are just to indicate. That's it. Nothing else.
Yes, I've done it.
Okay, now absorption spectrum. It was an emission one, now absorption. Now check it out. Check it out. An atom can be raised to an excited state by the absorption of photon. We know that. So when light passes through a cool, that one we already done an experiment in the last class, it is found that light of a certain wavelength are missing. This type of spectrum is called as absorption spectrum. An absorption spectrum consists of a continuous spectrum. Now, this is called the continuous. Did you notice one thing in this spectrum? There are mixed colors even in the one pattern. Did you see that?
Yes.
Now here the differentiation between the different patterns is not possible. All patterns are mixed together. So here it is continuous spectrum, not a discrete spectrum. Above one was discrete, that one was continuous. Why it is a continuous? Because the process is continuous. You are continuously providing the photons and electrons are continuously moving to the excited state. Okay. An absorption spectrum consists of continuous spectrum containing all colors with dark lines at a certain wavelength. These dark lines correspond exactly to the difference in the energy levels in an atom. When these electrons return to the lower level, the photons are emitted in all directions rather than in the original direction of the white light. Therefore, some wavelength appear to be missing, and the wavelength missing from an absorption spectrum are the same as their corresponding emission spectrum. Now, what exactly is all saying? You are providing a light, okay, photons, and electrons are jumping from one energy level to the another energy level. Remember that the energy which you are providing is continuous. That is the reason the light will be continuous one. It will be a mixed one, right? But remember that
Right.
once the electron taken up this energy and shift to the new energy level, it has to come back because the state which is called excited state is not the permanent state for that, or you can say unstable state. So it has to release it again, and that level will be that spectrum which that will be released afterwards is called as emission spectrum of the same element. So the one which you are providing is called as absorption spectrum, and the one which is actually you got it is called as emission spectrum. The one which you are providing is the continuous spectrum, and the one you are getting is a discrete because the one you are providing, you see that slowly electron will be shifting towards the higher energy level because the energy which you are providing is in your hands, right? So you see by how the
Right.
electron is getting the energy and shifting to the higher energy level. Let's check this out. You will understand. It's like this. Electron is going up. You are providing, let's suppose n is equal to 2. You are providing red light in this. Like here, it was coming out. Here, you are giving in. You are giving that light, then actually light, I mean, that particular thing is shifted into that energy level. So
What is
we
an example of this?
actually not there is a particular example for this because definitely it cannot be seen by the naked eye very easily. Because these are the experiments which will be actually done to understand the quantum physics. Now, if, for example, you have any chance, inshallah, in the future to go into quantum physics, then and only then there are some experiments for that, which will tell you that when the electron shifts from ground state to the higher state, you have to provide, let's suppose, red light. Remember that the light which is providing is a laser light, unicolor light. It's not
Yes.
like multicolor light, a white light. No, no, no. Then you provide it, then it will be shifted into n is equal to 6. Now, how it will be seen? Because once the light, I mean, once the electron will be shifted back into the ground state, it will release the same light. Okay. So
Okay.
that is what we call as absorption. Now, this is your energy level thing. How do you find out? Simply higher energy minus the ground energy. That is the formula of a discrete energy level. And then you will simply
Okay.
find out lambda by hc upon the formula was E is equal to hc upon lambda. So if you want to find out the light lambda wavelength, then what you can do, you will simply do hc upon E2 divided minus E2. If you can do that, you will simply find out the lambda of the wavelength of the one which is actually you achieve once you shift from energy level 2 to energy level 3 or energy level 3 to energy level 1. So this is the equation of, okay. I want you
Okay.
to just write these ones because these are, or just write these one, not a full one, but write as much as you can. This was the last topic of this line spectrum and the continuous absorption spectrum and everything. So this whole topic is finished, actually, technically speaking. So we have finished
Yeah.
the one you have just said.
Okay, done.
Done. Okay. Now just write the equation. That's it. Put a heading and write these two equations. That's it. This is the equation for the different in discrete energy levels. Okay, that's how our chapter also finished. And I hope we had a good time. So hopefully once you finish with your exam and everything, hope to see you again. All right.